Today we're going to be continuing to work towards our learning target of can I solve one-step word problems. Remember, our success criteria to meet our learning target is can I identify the whole and parts in a word problem? Can I identify what I know and what I don't know in a word problem? Can I explain how to solve for the unknown? Can I use a question mark in an equation to show the unknown? And can I solve the word problem using an addition and or subtraction equation and draw a visual to explain my work? So remember, when we solve word problems, we want to read the word problem 3 times. Each time we read the word problem, we're going to be thinking about a different part, but all of those parts together are going to help us understand how to solve the word problem and explain our thinking, which is going to help you meet all our success criteria and the learning target. So let's think. Our first read, we retell the word problem and say the word problem in our own words. For the second read, think about the numbers. So what do the numbers mean? Can you describe the numbers and explain how they're important? And for our third read, friends, we understand the question. So what is the question asking you to do? How can you explain how you're going to solve the problem? And then finally, we think about how are you going to solve the word problem? Which model are you going to use to show your work and show your thinking? Everything I say out loud, friends, is a really great way to break down the word problem, and it's a really great way to show that you understand your thinking. If you're able to explain your thinking the same way I do, then potentially you could be earning a 3 or a 4 if you're able to use all the words as well. Thinking about those words, let's review. We have the word start. So when I think of the word start, I'm thinking, what is the word problem starting with? Then I can think about our change. So our change is what's happening in the word problem. And our result. So our result is what happens after something happens in the word problem. That's our change. We can also think about the word unknown. And unknown is what we don't know in a word problem. That's what we're searching for and we're solving for. When we think about an equation, we can also think about parts. We can think about wholes and how we're going to write our equation. So let's think, are you able to use all these vocabulary words and explain your thinking for a word problem? If you are and you're successful at it, then you could be earning 4. Let's get started. Today, this is our word problem. There are 11 frogs at the pond. There are 5 frogs in the water. The rest are in the mud. How many frogs are in the mud? Okay, so I know my first read I need to retell the problem. So there's a pond, and there's some that are in water, and there's some that are in mud. Okay, think about the numbers for my second read. There are 11 frogs at the pond. There are 5 frogs in the water. The rest are in the mud. How many frogs are in the mud? So I know there's 11 frogs at the pond, and some are in the water. There's 5 in the water, and then some are in the mud, but I don't know how many are in the mud. Okay. So third read, how are we going to solve this problem? There are 11 frogs at the pond. There are 5 frogs in the water. The rest are in the mud. How many frogs are in the mud? Okay. Now I'm thinking, so there's 11 in the mud, and I know some of them, which is a part, are in the water, so that's 5, and I know the other part is in the mud because I'm really taking this pond and I'm putting it into parts because my pond is a whole. I think I'm ready to get started with this word problem. So let's think. We see that the rest are in the mud, but we don't know how many those are. So I'm going to put a question mark there. That's my unknown. I know there's 11 frogs, and that's my whole because it's how many total there are. And then I know there's 5, and that's a part, but I'm going to call that my change for now. And this is my result. Okay, so I know that I'm going to use a new strategy today, and that new strategy, friends, is called a bar model. A bar model is very similar to a number bond, but when I think about a bar model, The last time we solved a word problem, we used pictures, but when I draw pictures, it's not exactly the most efficient strategy. Last time we had 11, but maybe I would have 50. And I don't want to draw 50 circles to show my thinking. So look at how I can show my thinking with numbers in this bar model. So a bar model is a bar. So it represents the whole when I have the whole bar. But what I'm going to do is I'm going to put it into parts. And I'm going to show the whole by showing the whole thing, by labeling the whole thing. So I know that this was my whole, but it's also my start. So I'm going to write that up there. I know that there were 11 at the pond. So I'm going to write pond up here, because I know there's 11 in the pond. And I know that there's some in the mud and there's some in the water. So let's see, how many were in the mud? Oh, I didn't know. So I'm gonna put my question mark because I'm not sure how many were in the mud. But I do know there's 5 in the water because I see that right here. There's 5 frogs in the water. Okay, now when I think about this is my part, because this is also a part and this is a whole. So friends, remember when we write equations, we think part plus part equals whole, or whole minus part equals part. So we can use that thinking when we're solving this word problem. So I have 11 because that's my start. And I know that I don't really know how many are in the mud, but I do know that there's 5 in the water. So now I can rewrite this equation and I can think, how can I use my fact family understanding to write different equations to find the one that makes most sense to me to solve? So I can move these numbers around so my whole stays in the same spot because this is a subtraction equation, but I can move around my parts. So I can have those 2 subtraction equations, but I do remember the opposite of subtraction is addition. So I can write part plus part. So 5 plus question mark equals 11. And then I can switch my parts. So question mark plus 5 equals 11. Now I'm going to look at my 4 equations and I'm going to think which one is the best one for me to solve. So I think I'm going to solve this one because my unknown is the result over here in this equation. And so I can solve. Now I can think of a lot of different ways to solve. I could use make a 10 strategy. I could use picture strategy. So we could do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I can subtract 5. 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, 5, 6 left. So 6 plus 5 equals 11. So now I can think about, what was the question? How many frogs are in the mud? So now I need to answer that question with a sentence. So there are, I'm just going to take this sentence and rearrange it so I can answer the question. There are, and I solved already, there are 6 frogs in the mud. This, friends, is a bar model, and we're going to be using bar models a lot this school year. So I want you to think, what do you understand about using bar models, and what are you still confused about? What is something that you still are working on understanding and using yourself? See you next time.